Hello, in this video we're going to go over problem 24 from the 2024 University of Maryland High School Math Competition Part 1, which is a competition that I run every October. Let n greater than or equal to 3 be an integer. A regular n-gon P is given. We randomly select 3 distinct vertices of P. The probability that these 3 vertices form an isosceles triangle is 1 over m, where m is an integer. How many such integers n less than or equal to 2024 are there? Well, okay, so since this is a regular n-gon, we can think about the regular n-gon as the vertices on a circle. Now we are selecting 2 of the vertices to be the base vertices and 1 vertex to be the vertex of the isosceles triangle. So we can select A first, and then we can select the other 2 vertices. We have n minus 1 vertices left, and then we can choose B from half of the circle and C from the reflected of the point B. So that means the number of ways I can choose B and C would be n minus 1 over 2. And of course, I can choose A in n different ways. So this is how many triangles I can get that are isosceles. However, if n is divisible by 3, this triangle could be equilateral. So if it is equilateral, then every equilateral triangle is counted 3 times, 1 for each of the vertices. So the answer is in fact the number of isosceles triangles. Number of triangles would be n times n minus 1 over 2 when 3 doesn't divide n. And if 3 does divide n, it's n times n minus 1 over 2. That's how many triangles we have. Minus there are n over 3 equilateral triangles. We have to subtract 2 times n over 3 because each one of them is counted 3 times. This is when 3 divides n. In how many ways can we choose a triangle? That would be n choose 3, which is n times n minus 1 times n minus 2 divided by 6. So now what is the probability? The probability is the number of triangles divided by n choose 3. So the probability for n is going to be I'll take the n times floor of n minus 1 over 2 divided by that. N cancels, we get 6 times floor of n minus 1 over 2 divided by n minus 1 times n minus 2. This is if 3 does not divide n, and we do the same thing for the other one. We get floor of n minus 1 over 2. We can multiply by 6, so we get this minus 4 divided by n minus 1 times n minus 2. This is if 3 divides n. Now, in each cases, we'll have to see whether the fraction simplifies to 1 over something. Okay, but in the first case, we'll have to see whether n is odd or even. So 3 doesn't divide n, and 2 does not divide n as well. So this tells us that the probability is equal to 6 times. Since n minus 1 is even, this would be n minus 1 over 2, and then divided by n minus 1 times n minus 2. So this tells us 3 over n minus 2 must be 1 over n. So that means 3 must divide n minus 2. So 3 divides n minus 2 means n must be 2 mod 3, but n is also 1 mod 2 because it's odd. So that tells us that n, we can find n mod 6. So it's 2 mod 3 and 1 mod 2, so that would have to be 5 mod 6. So all of these numbers are going to work. If 3 doesn't divide n and 2 divides n, so P of n would be 6 times floor of n minus 1 over 2 is n minus 2 over 2. And then we'll have to divide that by n minus 1 times n minus 2. Simplifying, we get 3 over n minus 1. So that means 3 must divide n minus 1. So n would have to be 1 mod 3, and it would have to be 0 mod 2. So that means n would have to be 4 mod 6. So this is the first case when 3 doesn't divide n. The second case is when 3 does divide n. Again, we'll have to take cases. If 3 divides n and 3 doesn't divide, 2 doesn't divide n, this would mean the probability is going to be, so let's go back and see what the probability was. It's 6 times floor of n minus 1 over 2 minus 4 divided by n minus 1 times n minus 2. So the denominator is n minus 1 times n minus 2. 6 times floor of n minus 1 over 2, which is that because n minus 1 is in fact even, and then minus 4. So this is 3 times n minus 1 minus 4 divided by n minus 1 times n minus 2 in order for this to be 1 over something. So this means 3 times n minus 1 minus 4 must divide n minus 1 times n minus 2. If we take this guy mod n minus 2, we will see that 3 times n minus 1 minus 4 is equal to 3 times n minus 2 and then minus 1. So now this is obviously relatively prime to n minus 2. So this is relatively prime to n minus 2, which means 3 times n minus 1 minus 4 must divide n minus 1. So this means this quantity 3 times n minus 1 minus 4 would have to be one of these numbers, 1, 2, or 4. Of course, it cannot be a negative number, because again, the GCD between these two is at most 4. But what we know is, we know that n is 3 mod, n is divisible by 3 and n is odd. So since n is odd, this is even. So this would mean 3 times n minus 1 minus 4 would have to be either 2 or 4, which means 3 times n minus 1 would have to be either 6 or 8, and that means n minus 1 must be 2, so that means n is 3. So this one is not possible. 3 times n minus 1 cannot be 8, so n equals 3 is one possibility. And in fact, if you plug in n equals 3, which is in fact odd, we do get the answer as 1. Probability is in fact 1 for n equals 3. Okay, so this is one other possibility. Now, what if 3 divides n and 2 also divides n? Then P of n becomes 6 times, so let's simplify that. We get 6 times n minus 2 over 2 minus 4 divided by n minus 1 times n minus 2. This is going to be 3 times n minus 2 minus 4 divided by n minus 1 times n minus 2. Okay, so now we need to see when the numerator divides the denominator. So numerator is 3n minus 10, and this would have to divide n minus 1 times n minus 2. Let's find the GCD of this one and this one, and GCD of this one and this one, and then we can just ignore the rest of it. So if you take 3n minus 10 and take that mod n minus 1, n is 1 mod n minus 1, so this would be 3 minus 10, which is negative 7. And if you take 3n minus 10 mod n minus 2, then n is 2, so we get 6 minus 10, which is negative 4. This is mod n minus 2. So that tells us that 3n minus 10 would have to divide 4 times 7. And on the other hand, we know that n must be divisible by 6, which is something we found up here. So n would have to be 0 mod 6. So that would mean 3n minus 10 is mod 18, negative 10, which is 8 mod 18. So now we need a number that is going to divide 28 and is also 8 mod 18. Well, 8 doesn't divide it. 18 plus 8 is 26. That's also not going to divide it, and the other numbers that are 8 mod 18 are going to be larger than this. So there are no possibilities in this case. So bottom line is n is equal to 3, or n is either 4 or 5 mod 6, which is what we found in the other cases. And if we count this, we have n is equal to 4k plus 6k plus 4, and k ranges from 0 to 336, or n is 6k plus 5, and k has the same range, and finally n is equal to 3. So the answer is 1 plus 337 possibilities for each one of these. So multiply that by 2, and this gives us 675. So the answer is in fact B.